All right, so again, we're on worksheet 15. I forgot to push start recording, but that's okay. You just missed the boring explanations and intro. So we're on this Ferris wheel question, and again, the issue is students will often read this and say, let t be the number of seconds, so this is t, and this is his height. Rashad determines it takes him 3 seconds to reach the top. Okay, so people think that means that he started at the bottom and went to the top in 3 seconds, or that somehow we know exactly where he was here. What you want to do is you're going to need a phase shift. Okay, so he's at the top at 3 seconds. So 3 seconds, he's at the top, which it says is 43 feet in. So I'm going to call this some kind of a cosine graph, and I'm going to use that 3 seconds as a phase shift. Don't think you have to cram a period in or that it started at 0 necessarily. Most of these require a phase shift. All right, which is 43 feet above the ground. He also determines that he is back in his original position after 8 seconds. Now, I don't know what his original position was, but what that's telling me is that he had done 1 revolution in 8 seconds. Okay, 1 revolution in 8 seconds. So when is the end right here? If it takes him 8 seconds to go around, this would be at 11, he's back at the top. Is everybody okay with that? 3 plus 8. And he's back at a height of 43. Now, it says the diameter of the Ferris wheel is 40 feet. Okay. Think about that for a second. It does say there's something on the next slide. And it isn't working, so I put in a link. Let's see. I just wanted to show you real quick, in case anybody's unfamiliar with what's happening. Okay, maybe not. We don't care about the sound, but oh, there, thank you so much. This is what's happening, right? It's going up. His height is going up and down. But do you see that as time goes on, we can't have him go backwards in time, so it doesn't make a circle. So his height is all that we're graphing. Okay, let's try this. Whoa, kidding. All right. What is the lowest he goes? If all the way across here is 40 feet, what is the lowest he ever goes? If he's at the top, he's at 43. So, oh my goodness. 43 is his top height, but 40 is across, so at some point, his 3 feet off the ground at the bottom. Is that making sense to everybody? Okay, so 3 feet, why is it greater than 0? So he doesn't hit his feet on the Ferris wheel, that's where he gets on, whatever. Hit his feet on the ground, just that it's above the ground as it goes around, right? Dot, dot, dot. Okay. Write an equation. Check your equation by graphing on your calculator, and then we're going to put in some numbers on our calculator. Okay. The order we usually talk about things is we talk about the midline, and then we talk about the amplitude, and we talk about the period and where those things go in the equation. How do you find midline? Do you remember? It's the middle. What's the good thing for a middle?
You add both together.
Yes, average. So 43 plus 3 is 46, divided by 2 is 23.
Take away the low point and high point.
Okay, you can take away and divide by 2, or since we found the midline, how far above and below that midline is it going? Okay, and that should be the radius when you have a circular Ferris wheel going on. The radius tells you how far above and below the middle. Does that make sense? The middle of the Ferris wheel, above and below. Okay. So students often get those in the wrong spot, though. I don't know why they do that. Which one goes out in front? Do you want to do this as a sine or a cosine? So we have A cosine B x minus C or plus C, it doesn't matter, plus D. Okay, so A is the amplitude, which is which number? The 20. So this has, the height has an equal sign here, so I don't have to write that. 20 cosine. Okay, the next thing that goes in is related to the period. What is the actual period of our graph here? Not 11. Okay, you have to be really careful. It is the length of one cycle. It is not 11. Yes. Okay, 8 seconds. So how do we find the B value? Always 2 pi over that that period. So 2 pi over 8 or pi over 4 is going to go in here. Do we have a phase shift that we need? Yeah, it started to the right 3, which would be minus. And where does what goes on the back, guys? The midline, right? So plus 23. Students often get the 20 and 23 in the wrong spots, and that messes them up, okay? Now, we're going to put our calculator in what mode? We need to be in radians. Make sure none of these stat plots are turned on up here at the top. Should say radians at the top of your screen. And then we had 20 cosine pi over 4, parenthesis, x to the right 3 was minus 3, close both parentheses. And then plus 23, how did I do? Is that what we said it should be? Okay, we need to pick an appropriate window or this isn't going to make any sense though. X is time. Now, I don't know, if you look at the questions, we have to answer these questions down at the bottom here. Predict your height at the time 6, 4 1/3, 9, and 0. So it doesn't go out super far. So I think if we don't make our window out too far, it's okay. I'll maybe go 15. What about the Y? The Y is the height. So 0 to like 45 or 50. Yep, perfect. Now, what do I want to check before I try to find an answer? What was an ordered pair I knew? 3, enter, is at 43, okay? And 11, enter, is also at 43. So it seems like we're working. All right, so once you have it graphed correctly and you're confident in your equation, then you can use the graph or the table to predict these 4 right here real quick. So using this at 6 seconds, it's at 8.9. We can round to the nearest 10th feet. Rashad is at that height. What was the next one? 4 1/3? 4, I could do plus 1 divided by 3. Was it 1/3? 33. What else? 9, did it ask? 9 is 23, because it's at the midline, I think. And then, was it at 0? He was actually at 8.9 when he started the ride, according to the equation that we wrote. All right, I need somebody to remind me of those. What did we get at 6? 8.9? And at the end too, right? And then this one was 33 and 23. Okay, and those are all feet, so I'll put my label on those real quick. All right. So tell me something that you're going to be real careful about. Right, and that you check that the equation is in your calculator right before you use it to make a prediction. Make sure you're in radians. Okay, but what was it about writing the equation that was a little bit tricky? Okay, the midline and the amplitude, you put those in the right place. And one of the things we talked about was that the length of the period is not necessarily where it ends, right? Be real careful. The length of the period was 8, not 11. Okay. Now we have a bouncing spring problem. Do you remember the video that we started this whole unit with? The little harmonica no. Okay. There was a weird video. It showed all kinds of different things. And one of the things it showed was a spring. Okay. Or a piston it showed. All of those things repeat, right? So a bouncing spring is something that you can measure. Now, due to friction, it will not continue the same pattern forever, right? But the idea that it will start out making the same repeated motion. A weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the watch reads 0.3, it reaches its high point. Okay, so at 0.3, it is at its max. We don't know anything about where it started at time 0. We're going to need a phase shift. Everybody good? Okay, and that was 60 centimeters up. The next low point at 40 centimeters above the ground occurs at 1.8. Sketch a graph of this function. Now, if that's a high and that's a low, is that a period? No. Assuming that there's no friction, it will continue to go back and forth between those. So can we figure out what a period is? Because this is half a period. Everybody get the idea that's going on here? It does say your graph will not show a whole period. One of the questions on the quiz, I believe, is like that, where it only describes half a period. And you have to figure out the length of a whole period. Okay, so tell me what you know. Okay, the amplitude is 10 because the midline would be where? Yes, halfway between 40 and 60 would be 50. So above and below that, the amplitude would be 10. Okay, so we're going to have 10. You think you want to call this a cosine or a sine? Cosine, because we know where the max is. Okay. Now, at the end, then we're going to have a plus 50 for that midline, right? And do you know the phase shift? So in here we could have X or T, which I probably wrote X on the last one. I always use X. Minus 0.3. Everybody okay with that part? All right. Now, the trick to this one is the period business. All right. If it started at 0.3 and half a period was to 1.8, how long of a time did that take? 1.5, but that's only half a period. So the whole period would be 3 seconds. Yes. If the period is 3 seconds, then B is going to be 2 pi over 3. Did I throw the rest of the equation together too fast for you, or are you okay? Midline was the average, that one at the back. Amplitude was the distance above and below the midline. Phase shift because it started its maximum at 0.3. Could we do that as a phase shift with a negative cosine? We could have said, you know, at 1.8 it was at its min, but Let's not complicate things. Okay. So then we're going to go to the calculator. And I already forgot. Was this 10? And then this was 2 pi over 3. And the shift was 0.3 to the right. Is that right, guys? And plus 50? Okay, totally forgot there for a minute. All right, so I don't think my window is, I could leave it 15. I probably don't need to go out that far because it's going really fast, right? Maybe I'll change that to like 10 or even 5. It's going to go up and down a whole bunch. But it goes up to, what do we need here? At least 60? Okay. Okay, maybe I'll even make it a little more. Okay. Now, it's not the same scale we used here. We could have definitely changed this, like, to have a Y min of 20 or 30 or something, but it's okay. So what 2 points might I want to check? Trace 0.3. It's supposed to be a height of 60. Is that what we said? And then 1.8. It was at the min of 40. Okay. And what times do they want to know? Distance from the floor at 17.2, is that what that says? So trace 17.2. Does anybody know why I got an error? It's not in the window, yep. I usually check that before I pick the window. If you do go to, yeah, it didn't help, okay. So I need my time to go out to like 20 seconds, which by the way makes the graph really little. Trace 17.2. Okay, so I have that it's at 43.3 centimeters, was it, guys? Above the ground on its like 1, 2, 3, 4, 5, going on its 6th cycle or something. Okay, what was the 43.3 centimeters? Okay, and what was the distance from the floor when you first started the stopwatch? So at time 0, I have 58.1. Anybody else? Everybody good? Any questions? All right, you want to try one on your own? See how far you can get on this one. I'll stop the video and give you a... So it is confusing. So what happens is the water first goes down from its normal level. So if the normal level is 9 meters, and it says this one has an amplitude of 10, well, the water level can't go below 9 meters, but what could you see from the shore if the water level goes down below what it normally is? Yeah, you would see the sand, you would see the ocean floor, right? So you would see the water receding. And that's what happens. If you're ever standing there and you see the water receding, and all of a sudden you're like, wow, really quickly this water is, it's not like low tide, it just keeps going out, okay? Then that's the sign that a tsunami's coming, and run, okay? So it normally has a depth of 9, but this recedes down to 1 below because it says the amplitude is 10. How high does it get then? Yes, because 19 meters, which is, yeah, like 3 or 4 meters would be a floor, like 10 feet. So 19, yeah, almost 60 feet, like a 6-story building coming at you. But remember, it's built, I'm sure the area is built to withstand 9, so, because that's the normal depth. Anyway, let's keep going here. What do we know? It says it starts at 9, right, and it recedes? And then it comes in and does this? Does that seem right? And the period is about 15 minutes. So do you want to call that a cosine? What do you want to call that one? A sine? Do you want to call it a positive sign, a negative sign? Negative sign, and then we won't need a phase shift? Okay. Negative sign, but what goes out front? The amplitude, which they told us, and the problem was 10. Okay, they told us the period was 15 minutes, so the B would be what? Okay, and it's always best to just leave that in exact, just type 2 pi over 15. Do we need a phase shift? Okay, and the vertical shift, or the midline is at 9? No. You could leave off the inside parentheses, and I'm almost positive that it will work. All right, so the amplitude was 10. We did a sine. Oh, we did need a negative, thank you. Two pi over 15. And I'll put the parentheses and you not put the parentheses, and we'll double check. I'm positive it's going to work. And then it was a normal depth of 10 or 9, so that's our midline. Does that seem good? The time, did anybody look at the bottom of the question? How far out do we need to go here? 12 minutes it talks about. So I'll just leave mine 0 to 20. But I need a min of like -5 to, went up to 19, does that sound right? So I'll do like 25. How's that looking? So what did we know? At time 0, it was at 9, and 15 minutes later, it was back. Those are the 2 times I checked to make sure it's working. And it worked without the parentheses? Okay. The inside parentheses were unnecessary. Okay. Predict the depth at the following times. At 2, I have 1.6. Everybody get that? What else does it ask for? 4 and 12. 4 is -0.9. And 12 is 18.5. All right, someone tell me what we just said. This was 18.5. That's the best I can remember. And that was meters? Okay, according to your model, what will the minimum depth of the water be? -1 meter. How do you interpret this in terms of what happens in the real world? I'm just going to say the shore line, or the water would recede. I don't know how you spell that, recede. Probably not like that. Did I spell right? The shoreline would show more. I don't know, you'd see all the little starfish clinging to the bottom down there, right? Or something. All right. The wavelength is the distance from one crest of the crest of the wave travels in one period. It's also equal to the distance between 2 adjacent crests. If a tsunami travels 1,200 kilometers an hour, what is its wavelength? Yeah, what is our period? travels in one period. The distance it travels in one period. The period is 15 minutes, right? Okay. So 15 minutes times 1,200 kilometers per hour. We can't do unless we change something to hours here. What can we do with that 15 minutes?
A quarter.
Yeah, you could just change it. Multiply or divide by 60 or make it 0.25 of an hour. So now the minutes divides out, the hours divide out, and its wavelength in kilometers would be 300, wouldn't it? Because 15 divided by 60 would be 4, goes into 1,200, 300 kilometers. So that's a lot of water to travel in 15 minutes, right? We didn't use the meters in the equation here because it just was the length of the period. Okay, so I think we're okay. I'm going to move on because I don't think that's going to be on a quiz anyway. Oh, do you have this number 4? Okay. When a satellite or rocket is launched into orbit from a site like Cape Canaveral, which is not on the equator, it actually goes into an orbit that takes it alternately north and south of the equator. Its distance from the equator is approximately a sinusoidal function of time. Suppose that a satellite is fired into orbit from Cape Canaveral. 10 minutes after it leaves, it's at its furthest north of the equator. Okay, so what do you think we're going to do? Do you see the little picture over here? So it starts out somewhere up here, right? North of the equator, but it hits at what, 10 minutes? Is that what it says, 10 minutes? It's its furthest north, which is 4,000 kilometers. So it started north, but I don't know how far north. So I'm going to need a phase shift, and I'm thinking a cosine graph, because that's its furthest. All right. Half a cycle later, it reaches its furthest south of the equator, which is 4,000. So I'm thinking we call that negative 4,000 because it's south. Does that seem okay, guys? And the satellite completes its orbit in 90 minutes. So it goes back up here. The entire length is 90 minutes. Do you get what they're telling you guys? So what is the label on this point which it returns up here? It's not 90, it's what? Be 100 minutes, and it would be back at 4,000. The 90 is actually what?
90 minutes.
Is the period. And if you do 2 pi over 90, it reduces, but I'm okay if you even left it 2 pi over 90. I don't care, okay? It does go pi over 45. All right, what can you tell me? Okay, the midline is 0, so we don't need a what? Vertical shift, okay? The amplitude is 4,000. Do you want to use cosine or sine? Cosine. And do we need a phase shift? To the right 10 minutes. And what are we going to put in here? Either 2 pi over 90 or pi over 45. Okay, we don't need the plus 0 on the end. I just wrote it to remind us that we didn't need one. Okay, I'm looking at the next question before I type this in. It looks like we go all the way out to 163. Everybody good? So we need our window to be pretty big. All right, I already forgot. It was 4,000. Cosine pi over 45. Parenthesis 10 minutes. And we didn't need a up or down. Our window, though, is got to go out far, right? What did I say? How far did it say? So if I go out to 170, and what do my Y max and min need to be? Okay, so I'm going to do negative 4,500 to 4,500, but you can do 4,000 to... Well, of course I can't do that right, but I'll try. All right. So 10 minutes in, so I'm going to do trace 10. It's supposed to be 4,000 above. And 90 minutes later, which would be 100 minutes after it's fired, it's back at 4,000 north of the equator. Does that seem okay? So my equation is working. I'm supposed to predict its distance from the equator, include labels of north or south. So at 25 minutes, it is 2,000 north. Is that what you got? And what's the next one they ask for? 41 minutes in. It is 2237 south. And then was it 160 something? 163. It's about 1,236 south. Okay, we got 1230, can't write. 1236 south. What was the one before that? 2237? That was also south. And this one was? Thank you. All right, calculate the distance of Cape Canaveral from the equator. Oh, and they gave us a hint, use time 0. Okay, so that's where it was fired from. So if we put in a 0, we get 3064.2. If Cape Canaveral, and I looked this up online, and it says it's actually 3154 north of the equator. So are we getting a reasonable answer? About 90 kilometers off. Now, if that 90 kilometers doesn't seem like, it's not a big percent of error. In actuality, if you were 90 kilometers away from where it took off, it would be a big distance, right? But we're getting something reasonable. Okay. Yeah. All right. Look, when I was being evaluated, I had an extra credit problem, ticket out the door. You were supposed to write your own problem. Yeah, I was being extra special. I think this is right, though. You need to do worksheet 16 and 17, and did I circle the ones you have to do? Most of the extra ones I think I just took off and deleted. Yeah. So you pretty much have to do all of them that are there because I wanted to fit it on as much or as little paper as I could. Okay?
All right, we don't have to do 17B.
What is 17B?
It's this one. Oh.
Got like
What page is it?
page 277.
Is that on the homework check?